All right, so now we're ready to play the game of Gauss-Jordan elimination. And for reference, I've listed the legal maneuvers up here at the top. These are the legal row operations, and that's it. That's all the legal moves you can make in this game. You can interchange two rows. That's what this first one is indicating. We can interchange two rows. We can replace a row with a constant multiple of itself. That's what this one is indicating. And number three, we can replace any row with the sum of that row and a constant multiple of another row. Okay, that's what this is indicating. This is kind of the shorthand notation for that row operation. All right, so this is just here to remind us what the legal row operations are. And the goal of the game is, let me just write that down too. The goal of this game is to create a matrix that looks like this: 1, 0, 0, 1, and then some numbers. I'm just going to put asterisks here. All right, we want a matrix that looks like this in the end. That's our goal. That's how we know when we've captured the king. All right? We're done when we get to that point. So, first thing we're going to do is start by just rewriting the system of equations as an augmented matrix. Okay, so I'm just going to take the coefficients of each of those variables. So 2, 5, 3, and then minus y is the same thing as a negative 1 times y. So this is a negative 1. And then over here on the right-hand side, I have 1 and 10. Okay, so that's my augmented matrix. So I'm going to take a look at this matrix and think about what my goal is. And I'm going to work one column at a time. Okay, so I'm going to start with the x column and try to get a column that looks like 1, 0. So the first thing I'm seeing here is that if I subtract row 1 from row 3, I'll get a 1 in the first column. It won't be where I necessarily want it, which is in the upper left-hand corner, but I can always swap rows. So first thing I'm going to do is take row 2 and replace row 2 with row 2 minus row 1. Okay? And when I do that, I'm going to leave the first row alone. So it's just 2, 5, 1. And then when I subtract 2 from 3, I get 1. I subtract 5 from negative 1, and I get negative 6. Okay, and that's my vertical bar. And then when I subtract 1 from 10, I get 9. All right. Now I would like a 1 in the upper left-hand corner. So my next move is just to swap rows. I'm going to swap row 1 and row 2. Row 2. All right, so I'm just going to put the first row, I'm going to make the second row the first row. So 1, negative 1, or sorry, negative 6, 9, 2, 5, 1. All right, so all I did is swap rows. All right, so now I have a 1 where I want it, and now I want a 0 below it. Okay, so I'm working one column at a time. That's kind of a strategy. It's not a hard and fast rule, but it's kind of a strategy I use as I'm doing this. All right, so what I'm going to do is I'm going to multiply the first row by a negative 2 and then add it to the second row. All right, so I'm going to make a little notation for myself here. I'm going to take the first row times negative 2, but I'm not actually going to replace it with that, the negative 2 times that row. But I'm just going to make a note of what that will be. If I take 1 times negative 2, I get negative 2. If I take negative 6 times negative 2, I get a positive 12. And if I take 9 times a negative 2, I get negative 18. I'm just making a note to myself, just so that I don't get messed up when I'm trying to multiply and then add. Okay, so I've done the multiplication. Now all I need to do is add. All right, so I'm going to take row 2 and replace it with row 2 minus 2 times row 1. Okay, that's my next row operation that I'm going to do. All right, so now I'm not actually going to change row 1 though. So this is just going to remain 1, -6, 9. And then I'm going to take 2 times row 1 and add it to row 2. So it's going to be -2 plus 2 is 0. 12 plus 5 is 17. And then -18 plus 1 is a -17. Okay. So now you can see that I can just basically take 1/17 of row 2. That's probably the next logical step, because I'm done with the first row, right? I'm all done with the first row. I've got the first column. I've got the first column the way I want it. I want a 1 with a 0 below. In the second column, I want it to look like a 0 with a 1 below it. So you can see if I just divide that second row by 17, I'll get it. So I'm not going to do anything to the first row right now. I'm only going to divide that second row by 17, or think about it as multiplying it by 1/17. So I get 0, 1, and then -1. All right, we got one more thing we need to do. We need to take care of this -6. We want it to be a 0. And so you can see if I multiply the second row by 6, so if I multiply 1 by 6, I get 6, and this becomes -6. So I'm just going to make a little note to myself. Those red numbers are just a note to myself. And then I'm going to add 6 times the second row to the first row. So this next row operation is just basically replacing row 1 with row 1 plus 6 row 2. 6 times row 2. Okay. And I've made a note of what 6 times row 2 looks like. So when I do that, I get, well, basically this is 0. If I multiply it by 6, it's just 0. So then I add that to 1, I get 1. And then 6 plus a -6 is 0. And then 9 plus a -6 is 3. And then I'm just going to leave the second row alone. So it'd be, because it's the way I want it, right? I've got a 0 and a 1 and a -1. Right? All right. So I have this is my goal, right? I've got it now. I'm at my goal, right? This is the goal. Right? So I'm there. I won the game. All right, there's my goal. Yes, I won the game. So I won the game. That means I can rewrite this and find out what x and y are, right? Because if I just take this augmented matrix now and write it as a system of equations, I just have 1x plus 0y is equal to 3. Right? That's what that first row of that augmented matrix is telling me. The second row is telling me 0x plus 1y is equal to -1. So my solution is 3, -1. Now it's always worthwhile to check, because it's so easy. It's so easy to make a little arithmetic mistake and then you get the wrong answer. All right, so it's always good to check. So all I need to do to check is take this x and y value and plug it back up into the original equations, right? So x is 3, so 2 times 3 plus 5 times y, which is -1, that should equal 1. Now, 2 times 3 is 6. 5 times -1 is -5, so 6 minus 5 is 1. So check. That one checks out. Let's check the other one. So 3 times x, and my x value is 3, right? And then minus a -1 should be equal to 10. So you can see 3 times 3 is 9. Minus a -1 is the same as plus 1. And so 9 plus 1 is 10. It checks out. All right. So I've got my answer. This is a solution to the system of equations. It's a point that satisfies both equations. All right. All right. So the next example is one for you to try on your own. So give it a go. Try it. So you're just going to write the augmented matrix. Make sure, you always obey the valid row operations and don't do anything other than those valid row operations. And you know what your end goal is. You want something that looks like this matrix where you have 1, 0, and 0, 1 on the left-hand side with some numbers over here. All right, so I'll meet you in the next video to go through it.